Thanks for the introduction. It's wonderful to be here speaking along such esteemed leaders and thinkers in the space industry. It's been really exciting to learn about the new directions and applications and developments within our international space community. I expect that many of my colleagues, if they were here, would argue with me, but I do feel like I have one of the best jobs at Surrey Satellite Technology Limited. I get to immerse myself across a lot of different types of missions, from Earth observation, technology demonstration, communications, science and technology. And to give you a feel for the different missions that we work on, the smallest satellite in our clean room at the moment is probably about the size of 2 soda cans stacked one on top of the other. And the largest is a bit taller than a double-decker bus that you've probably seen around London. So we really do work from the very small nanosatellites up to quite large spacecraft that are designed to work in geostationary orbit for 15 years. I've got the clicker. So this photograph here gives you an overview of our capabilities at Surrey. We punch well above our weight in the industry, missions that cover a broad range of satellite sizes, and what you can see here in the top right corner is our clean room. We also fly the satellites that we build for our customers as well. We have 500 people, mostly engineers, and our philosophy for delighting our customers hinges on a highly vertically integrated approach to designing, manufacturing, testing and operating our satellites. And when I say vertically integrated, I really do mean that we have resistors coming in and metal coming in, and we ship out fully integrated satellites ready for launch out of the door. Why is that important for SSTL? It really is key to our philosophy that we manage everything in-house. If we get a unit that we procure externally delivered to us, it's essentially a black box. We don't really know how it works inside. All we know is that it has a spec sheet and they tell us this is what it does. We don't really get a very good view or visibility of how it's designed and how it works. And the problem with this is that it doesn't allow us to leverage our systems engineering approach to tailor and tune the performance of every individual element in the spacecraft to suit our specific needs for each of our customers. At SSTL, it's the same module engineer that will design the module, test it once it comes out of manufacturing, and then they will test it once all of the modules on the spacecraft come together in integration. Once it's launched, they will then carry on testing and validating the spacecraft modules as they work individually and as an integrated spacecraft. And what that enables us to do is to get that in-orbit heritage that will allow us to feed back in and innovate and understand how that works and feed that back into the next generation of our spacecraft. One of the things that we're very proud of is that we build everything in-house, from the computers, the communication systems, GPS receivers, the structures, solar arrays, mechanisms, everything. And some of that hinges back to what Dr. Terrier was talking about. We've had to innovate and develop things that didn't exist. And the reason they didn't exist for us is because our vision at Surrey Satellite Technology is to change the economics of space. So we're always looking for cost-effective ways to deliver our spacecraft. Things just didn't exist at the price point we needed. They didn't exist externally. They were an order of magnitude too expensive. So we had to design and develop everything ourselves in-house. In the space industry, reliability and heritage are critical. If a satellite fails in orbit, there's no way to fix that, at least not cost-effectively at the moment. I mean, many of us in this room are aware of a growing trend and interested in orbit servicing, but that's really been for the exquisite assets. We saw photos that Dr. Terrier put up of the International Space Station, and he talked about the Hubble and looking out into space and looking far into deep space. Those are really the only two examples where you've had in-orbit servicing where people have actively been involved in building and repairing assets in space. And until that becomes ubiquitous, once the spacecraft are launched, that's it. They have to survive uninterrupted until it's the end of their mission. So evidence of in-orbit performance is really critical for all of our customers, and as a result of that, we've built up quite a nice little sideline in selling our subsystems to other companies. They value the fact that we have a lot of in-orbit data and heritage and reliability built into our spacecraft, and they come to us and they say, we want to fly what you're flying. Can we buy some of your components at the price point and that allows us to provide a competitive service to their customers as well. So SSTL was started over 30 years ago by Professor Sir Martin Sweeting. Sir Martin is our company founder and he's our executive chairman, and he's still very active in ensuring that we leverage new technologies and stimulate demand for new ways to develop the space economy. We're known as the original small satellite pioneers through demonstrating a very different approach to space missions. We've disrupted the satellite market based on using commercial off-the-shelf components, mainly driven by the use of components that were originally developed for cars. And the reason that we've looked at cars is because they have to be very high reliability, they have to be trusted before they will be integrated into any vehicle that goes on the road. Safety is really important. And you may not realise it to begin with, but there are a lot of similarities between the components that you need to fly into space and the components that go into cars. Cars have to operate at very wide extremes of temperature, from very cold to very hot. There's a lot of bumping that goes on in cars and lots of vibration, and that kind of quality and material properties is the sort of thing that you need when you're launching spacecraft. They have to survive the launch before they can even begin to operate and start their operational mission. We launched the first commercial spacecraft back in 1981. Since then, we track the market very closely, and today we've identified over 25,000 spacecraft that are scheduled to be launched or planning to be launched in the next decade or so. Now, most of those, or many of them at least, may not make the leap from paper to orbit, but it's a really strong indication of the growing demand and interest in commercial space. Before I move on, I wanted to take a moment to acknowledge the role of NASA right at the beginning of Surrey Satellite technology, when it really wasn't even a company. It was still a small department at the University of Surrey. It's a little bit hazy, the details of how Sir Martin managed to get his first 2 launches, but our first 2 satellites were launched on Delta rockets from Vandenberg Air Force Base. And Dr. Terrier talked about the 2 roles that NASA has, one of really stretching the boundaries and the other one of helping to support and enable commercial businesses to thrive. Well, NASA gave us the springboard to prove the commercial approach to space and really set us on the road, so thank you. One of those first satellites, USAT-2, was launched in 1984, and believe it or not, it is still working. It's very much a senior citizen now. It doesn't always appear to hear us when we talk to it. And sometimes it doesn't reply back when we want to talk to it, but every once in a while we get reassuring beeps and we're assured that it's still up there and hanging in there. So far I've talked about where we came from and what we do and how we do it. And now I'm going to turn to our vision of the future and what capabilities we think we need to develop at Surrey Satellite Technology to serve the communities of the future. There's been a common theme across all the speakers that we've heard so far in this session, the fact that we think humans are going to become an interplanetary species, and in fact there were 2 announcements today that are very strong indicators of the drive for that, coming from a partnership between NASA and the Russian Space Agency, and also Elon Musk talking about his vision for Mars. So it's very much at the front of people's minds in the industry right now. And what we've seen recently is that the ecosystem and the mindset and the environment is changing, and there's an ecosystem that's starting to develop that's able to support the execution of this long-term vision for humanity. This beyond Earth ecosystem includes government institutions and commercial firms, the entrepreneurial firms, the rest of industry that have the necessary financial backing and the organisational capabilities and the resources that will help and contribute to develop this interplanetary railroad, as I'm calling it, or in other words, the infrastructure that provides the transportation and also provides the resources and the services as well. You can see some pictures here of some of the current events that people are thinking about, some of the current projects. NASA led the way with its missions to the orbits and the surfaces of the Moon and Mars, and the European Space Agency has got its own plans to develop a moon village. Elon Musk is planning to go to Mars as well. And one of those critical enablers for space transportation and exploration and habitation is the acquisition of the necessary resources, primarily water for life sustainment and propulsion. We've heard from Naveen talking about splitting water into hydrogen and oxygen and using that for propulsion. At Surrey, we flew the first water-based propulsion system, so we can actually use the water itself as the fuel. So water is a really critical enabler for us to be able to use as a staging point to go out further into the solar system. We also need the raw materials and the metals that can be used for in-orbit construction, either in orbit or on the surface of those two bodies. So in addition to the space agencies, we've got the commercial firms such as Planetary Resources and Deep Space Industries who are developing missions to capture asteroids and mine these near-Earth objects for the resources that we need. And the fact that there are more commercial companies playing a part in this is an indication that there are many converging trends that are creating the right environment for commercial services to be developed and to ultimately thrive. So I see this as a win-win between the government and businesses that are willing to collaborate and invest together for the long term. And we've been thinking about the factors that will drive the need for commercial services on the moon. And they really fall into four main areas. There are the enablers for the people who want to go, and people like Moon Express, for example, they fall into the group of people who need to go, who want to go and need to go and be there. There are also the wider competency and market trends that will either stimulate or create the new businesses and the opportunities and the capabilities that will get us out away from the Earth. What we've noticed is that many of the people who want to go to the moon and the Mars, they're focusing very much on their own missions and their own applications, whether it's science or exploration or habitation. One thing that all of these missions will need is a way to communicate, and the other thing they'll need is a way to navigate. For those of us on Earth to be able to communicate to everyone who's off the planet and vice versa. And I don't think there are many people in the room who don't use GPS in some form or other, maybe to get here or even to check when their Uber driver is about to appear and see it on a map. Most of us use those location services based on the GPS system. Well, we're going to need a similar system to provide the navigation services for the moon and for Mars. I'm going to run a short film now that shows what SSTL's role is in creating a railroad to the moon. And once we've demonstrated this, we'll be moving on to Mars. it looks like I'm nearly out of time, and I would have loved to talk for longer about our plans for our lunar mission, but I'm really looking forward to hearing what Ben has to say. So I'll draw it to close, and draw it to a close now. And in my closing comments, I'd like to say I'm grateful for all of you listening to what we have to say here today, and our talks about what we think the future of space is going to look like beyond Earth, and to give you an idea of what a small company in Guildford is doing to continue to change the economics of space. Thank you.
Thank you.